Have you ever contemplated where did the universe come from? Did the universe have a beginning? What exactly is time? Is it possible to travel back in time? So on and so forth. Well, if you have, then today's book review will be beneficial for you. Hi there, welcome to another Red Pill Read book review. I'm your host Neil. In this video, I'll be reviewing a popular science book, and I'm sure even if you haven't read it, you must have heard about it. This book is titled A Brief History of Time, and it's written by Stephen Hawking. I would call this book a crash course for anyone who would like to familiarize themselves to the mainstream ideas of physics and chemistry. And please note that I'm reviewing the 10th edition of this book that was published in 1998, whereas the first edition was published in 1988. Compared to the first edition, the content of this book has been updated. In the first edition, Stephen Hawking made certain predictions about the nature of the universe, which were later confirmed to be true based on observational and theoretical results, and he has mentioned them in the 10th anniversary edition. Along with that, this edition also includes a new chapter on wormholes and time travel. Now about the author, Stephen William Hawking, better known as Stephen Hawking, was an English theoretical physicist, a cosmologist, and an author. Dr. Hawking could be considered as a pioneer in the world of physics, as his formulated theories and predictions were groundbreaking. Some of his famous contributions include the prediction that black holes can radiate photons, which is today referred to as the Hawking radiation. Another one is the Hawking singularity theorem, which states that before the Big Bang, all the matter in the universe was confined into an infinitely small and infinitely dense point called the singularity. Besides The Brief History of Time, some of the other prominent books written by Stephen Hawking include The Grand Design, The Universe in a Nutshell, and Black Holes and the Baby Universe. In A Brief History of Time, Stephen Hawking talks about the two major theories that explain the universe as we know it. The first one is the general theory of relativity proposed by Albert Einstein, and the second one is quantum mechanics. Now, both these theories do an amazing job in explaining the macroscopic and the microscopic, but the problem is these two theories are not compatible with each other. And the central theme of this book is the search for a unified theory, which Stephen Hawking calls the quantum theory of gravity. One of the biggest revelations for me in this book was the fact that time is not absolute. Now, what it means is that, let's say you and another person are measuring time using identical clocks, but the difference is you're measuring the time from Earth, and the other person is measuring it from the International Space Station. Now, time would pass slower for the person who's in the space station compared to your time that you're measuring from Earth. Which also means that the person in the International Space Station would age slower than you. And please keep in mind that this idea from general relativity is not just a theory, it has practical implications as well. The navigation systems that we use receive their signals from satellites, and to provide precise location on the GPS system, this time difference needs to be taken into account. Back in school, you might have learned that an atom comprises of elementary particles like protons and neutrons, but this book reveals that this statement is not true. Protons and neutrons can be further divided into smaller particles called quarks, and based on our current understanding, quarks are the actual elementary particles. Along with that, it also talks about the four fundamental forces that govern everything that happens in our universe. These forces include gravity, electromagnetic force, the weak force, and the strong force. This book has got two chapters that are dedicated to explaining black holes. It talks about how stars are born as a result of giant hydrogen gas clouds collapsing on itself due to gravity, and how they die as the star runs out of its nuclear fuel. Now, what's fascinating about the death of a star is that a star could die in a variety of ways, giving birth to a black hole, a neutron star, or the white dwarf. And in 1931, the Indian-American astrophysicist Subramanian Chandrasekhar came up with the calculations that could help us determine how a star would end its life. According to the calculations Chandrasekhar made, a cold star that has a mass greater than 1.5 times the mass of our own sun will not be able to support itself against its own gravity. And this mass is known as the Chandrasekhar Limit. This chapter on black holes also takes us through a thought experiment in which it talks about what will happen to an astronaut that fell into a black hole, and what will a distant observer see as the astronaut is being sucked into the black hole. A common misconception that people have about black holes is that black holes are completely black and nothing can escape the gravitational pull of a black hole. But both these statements are not true, and to explain why, there's an entire chapter in this book called Black Holes Ain't So Black. Now, something that I felt this book lagged are illustrations. Now, I'm not saying this book doesn't have any images. It does have some. But they could have used a lot more, especially because this book is written for the layman. And later I came to know that this book has got another edition published in 1996 that contains full-color illustrations and photographs. So if you have plans to read this book, I would say go for the illustrated edition. You can find its link in the description below. Now if you're someone who's intimidated by equations, I've got good news for you. I've only encountered one equation in this book, which is Einstein's famous mass-energy equivalence equation, E equals mc squared. And recently I heard Neil deGrasse Tyson mention in his talk show that the original editor of A Brief History of Time warned Stephen Hawking that with every equation in the book, his potential audience will be reduced to half. So maybe that's the reason why Stephen Hawking didn't use too many equations in this book. Now when I looked up on Google, a common question that people have searched regarding this book is whether A Brief History of Time is hard to understand. In my opinion, I would say yes, some parts of this book are hard to understand, especially for a layman. When I was reading this book, I had to take a break and do my research on what does Einstein's general theory of relativity say, what's the difference between general theory of relativity and special theory of relativity, what is spin in quantum mechanics, and many other similar questions. Now I get it, it's not possible to dive deep into each of these topics in a book that's like 240 pages long, so as a reader, you have to do some research while you're reading this book to understand it better. Alright, so that concludes the review of A Brief History of Time. I hope now you know if you want to read this book or not. If you would like to read it, I've dropped a link in the description below for you to get a copy of this book. If you like this video, please hit the like button and subscribe to the channel if you haven't yet subscribed. I'll be back again with another book review. Until then, bye, take care, and happy reading.